No, my kind request, right? No, please don't record it. Let it be a trial class. Afterwards, we'll record.
That's not an issue. It should be also captured, recorded,
Oh.
so that you know when
Mm.
you deliver first class, what your level, and after you can say year, 2 months, when you come back and check that, then you will know that thing.
Yeah, that's true. Okay, now, okay, where to start from now? Evaluating the trade-offs.
How part? Yes.
Okay, okay, evaluating the trade-offs. Okay. Okay, there one. Okay, how part? Okay, there are many aspects of this how part. We have to take one by one. Okay, here one doubt is like how to evaluate the trade-off, either from the need point of view or performance point of view, or like that, Deepak.
Requirement point of view.
Okay, requirement point of view. Okay, fine. Okay.
Because in a requirement we will get everything. What is the
Uh-huh.
budget? What is the things? Based on that we can means
Okay.
go with those trade-offs.
Okay, fine. Okay, main is first, for example, see, we want, for example, let's say now somebody says there's a need for improving the this one performance of the application, or somebody's complaining that it is getting slowed down. Straight away, the moment somebody says we won't be in a position, we want to just take the action and quickly, for example, put another system or increase the RAM or whatever it is. Now, as we have put our monitoring and observability things in place, we just go and study those metrics, whether it is one-off incident or has it been happening over a period of time, and based on that, we take a call. For example, let's say now since last 1 month, now and then users were complaining, but we were not that keen to listen to their inputs. Then when we saw the monitoring report, we found that yes, somewhere it is getting slowed down. Then we see uh, which area needs the improvement. For example, the speed is a constraint. Again, in speed, is it because of load being very heavy, and does it require one more system? Does it require load balancers? Does only improving the RAM or improving the cache will suffice, or is there any other problem for the metrics to go wrong? So once we identify the core area where and what has to be improved, that area we supplement with, for example, additional servers, or put a load balancer in place, increase the RAM, cache, those things we do it. So in this way, like for us, the main tool is observability and monitoring systems. If they are in place, which will help us to go for this type of upgrades, or improve the performance when the users are complaining.
Okay.
This is one part which I can think of. The other one, 1 minute. Let me just think.
You can share your screen and use the document. That's not an issue.
Okay, I will open and then share the screen.
Yes, yes. I know.
Okay. Hmm. Okay, how to, yes, now I'll share it. Entire screen, yes, share it. Ah, is it visible?
Yes, yes.
Okay, so how to evaluate trade-offs and make engineering decisions in real systems. Okay. So now, I'm trying to be brief. Okay, let's try to come here. Yeah, okay, yeah, this is fine. Every design decision lives inside constraints. Okay, common constraints, definitely we have budget constraint, timeline constraints, yes, team size, or operational maturity, compliance needs, traffic expectation, latency requirements, reliability expectation. I will just very briefly tell each one, Deepak. Okay, so now budget issue, why budget can be a common constraint is the user may ask for something like all the features which he has seen in maybe in Amazon.com or Flipkart.com, so many other popular apps. So he may want all of those features implemented in his application, but unfortunately there is a very limited budget, so we cannot provide him all the required features. Based on the budget, what can be done, only those things can be implemented timely. Okay, timeline. Yes, this was another very crucial point. Now the user may ask, okay, see, I mean, within 2 weeks, I want to go full online, and then plus it should be like an app for anywhere, anytime application. So that means throughout all over the country, and also outside the country, people can order for items. Yes, those things, if he's asking, and if the timeline is within say 2 weeks, he wants everything up and running. Yes, definitely, it is not a feasible thing. It is definitely a big constraint. And within 2 weeks, I don't think so. We can provide him a big application with all the features what he wants. So definitely, timeline will become a constraint. Team size. Team size here. Uh, the team size is actually my problem. That is my company's problem. Right now, I have, say, example, only 4 resources time being. So I cannot put more team members, or I cannot add additional team members to enhance this application. It will be done gradually only, but right now it is a constraint from the companies. It is my side. Then operational maturity. Operational maturity, I'm sorry, this I have a doubt. Okay, I'll make a point of that. Then compliance needs, yes. Compliance needs can be, I mean, for example, security can become a compliance. When we are dealing with different countries, each country will have its own policies. So we have to comply with the rules and regulations of each country. The tax, when it comes to tax, each country will have its own tax policy. So we have to comply with all the state regulations. Only then it can be taken up. That is another constraint. Then traffic expectations. Yes, for example, during festival times, the extra traffic expectation is expected to be very high. During normal times, yes, the system is able to handle. But during festival times, on a specific day, maybe yes, the traffic may be high. So our application should be ready to handle that also. Then latency requirements. This again, this is purely technical. Uh, yes, as the users products are getting increased day by day, we may face some latency issues. But yes, but this can be addressed on the need basis. And then reliability expectations. Yes, again, this is like as in any other application or most of the popular applications, the moment I do a payment, within say 15-20 microseconds, I get an update. Within that, the delivery team gets an update. Then the whole process starts. So and whatever stock latest stock is available, that should be visible to all the users within a certain time, because users in one region should not see difference in the stock compared to the other users. So it has to be, the application has to be reliably working across the regions, across the users. Nobody should see any difference in the data, whatever they are seeing. So yes, so with these constraints, um, we have to design application. What is possible with the existing resource, existing budget, the compliance needs, all that has to be taken into account, and maybe probably version one can be released. Then later we can go step by step to give the advanced features, what the company requires based on the above constraints. A technically attractive design may still be wrong if it does not fit this. Yeah, correct. A technically attractive design may still be wrong if it does not fit. If it does not fit these constraints. Again, I have to come back on this. So 2.1 is operational maturity. I have something to say, but okay, that is one. And it's the last point. Fine. Then define success criteria. Okay, decide what good means. Example, response time, correct, 300 within a response under 300 milliseconds, 99.9% availability, launch in 6 weeks, low operational overhead, support 100K users daily, keep cloud cost under target budget. Response time, yes, that has to be like, yeah, there is a metric it has to be within the response has to be within 300 milliseconds. It's a metric. We simply can't say response should be good. That good doesn't have any meaning here. So it has to be told in terms of a number. So here it is 300 milliseconds. Then availability, yes, means it's almost equal to 100%. At any time, the application should be available. Then launch in 6 weeks. It depends, what features they're asking for, and whether let's say no, they have given the budget, everything is there, but I have a constraint with maybe with manpower, or even if manpower is there, the features what they're expecting, I'm sure cannot be done in 6 weeks. So I need to tell them that I may need more time, more than 6 weeks, somewhere around 8 to 12 weeks is what I'm expecting. The customer may demand maybe in a phased manner, we can release few features for him to start testing it or using it. Then in the background, work out on the other important features and add it. That can be done. Then low operational overheads. Again, this I need from business point of view. I have not worked on that. Then support 100K day. Okay, so this is one of the expectations. Okay, they are expecting a business of 100K every day. So our application should at least support 100K daily orders. Probably down the line after 1 year or 2 years, that 100K may become 200K. Yes, that time we should be ready to scale up. Our design should be such that anytime we should be able to gradually scale up as the number of users are getting increased or number of orders are getting increased. It should be designed right from day one. Then keep cloud cost under target budget. Yes, see, as everything has got a cost, you want all the features, availability, and 99.9% time availability. The response time should be within 300. All these are tied to something called as budget. If budget is there, yes, these things can be given, which is already told by many applications. If our application has to stand out among those applications, then yes, budget is a very important criteria. If that is there, yes, most of the things can be met. Then list plausible options. Okay, do not compare any one favorite option to nothing. Example, monolith versus modular monolith. Yes, okay, fine. To start with, we will go for a monolith application, and as and when the needs are coming, or as and when numbers of users are increasing, as and when there is a need for me to go for microservices, only then I will opt for it. Yes, there are huge benefits for microservices, whereby, for example, we have payment service separate, delivery services, order services, inventory services, payment services, delivery services. These are all separate. So now tomorrow, if one service is down, my application will still keep working. In case of microservices, in case of monolith, if one area fails, the entire application fails. I know the trade-offs there, but just because everybody is going for a microservice, I cannot go for microservice, because probably your business may not need at all. It may maybe just starting. So maybe daily some around 100, just 100 orders it may be able to cater to, which is sufficient for time being. So right now, I will never opt for any microservices. It will be always monolithic. Probably better will be a modular monolith. Modular monolith will be the option for me to start with. The database scaling vertically versus read replicas. Yeah, again, this also simply depends on the load on the database, the number of records, number of users. It just depends on the number of users, number of orders we executing, maybe per minute or per day, whatever it is. Simply just because it is very popular, it's a popular technology, starting the popular technology, or I should simply keep replicas in different regions. Well, for example, if my application is very much catered to Indian audiences, I don't think so. I need to keep servers in US or Canada, different regions. I don't need that. I don't need to keep the replicas of all that in different regions. Yes, I can start with local. Then when I go global, when the number of users are heavy, when the number of transactions are growing at enormous pace, then I need to think of keeping the replicas of the data, then do data sharding and scale vertically. All these things can be considered only when the number of transactions are growing exponentially compared to what I expected. That is there. Then sync workflow is asynchronous workflow. This is another point. Okay, 1 minute here. And yeah, operational maturity. Operational maturity. Then low operational overhead. Okay, that can be tackled. Yeah, here. Sync workflow versus async workflow.
Sync means user want instant response like
Reply.
confirmation of payment
Ah,
part,
yes.
or user can wait.
Yeah.
Let's say means payment will take some time. It
Time.
should be
Yeah.
run in the background.
Mm,
But
mm,
user want confirmation as soon as possible.
mm. So asynchronous workflow, asynchronous. Yeah. Now, if it is a monolith application, definitely it will be a sync workflow. If it is service microservices, then it can be asynchronous workflow. Whereas many things can happen in the back. For example, like the payment. Payment is a notification is pending. A notification is another service which can happen in the background. But the delivery team will be notified that an order is placed. You have to go and deliver it. So that will happen in the background, where notifications and updates can happen. So this is a good example for an asynchronous workflow. Then cache now versus optimize DB first. Yeah, little here, little technical. I will mark it, but I want to know more about it. I will come back on this. Cache now versus optimize DB first. Okay. Then next, accept that no option is perfect. Every option improves some qualities and weakens others. The goal is not perfection. The goal is the best fit for the current needs. Every option improves some qualities and weakens others. The goal is not perfection. The goal is the best fit for current needs. Some qualities. I want to give a good example for all this. Running short of examples. Fine. How to compare options properly? Fine. Compare against important dimensions. Good trade-offs analysis compares options across dimensions such as simplicity, scalability, reliability, performance, consistency, operational complexity, cost, speed of delivery, team fit, security impact. Okay, fine. Now, simplicity. See, now we should keep our application simple, don't make it too complex. Some examples can be like, don't try to automate too many things. Let there be some confirmations here and there, check it and then go and update us or inventory, for examples. There are certain areas which, doesn't need to be very complicated. Keep it simple and make it work all the times. That is simplicity. Then scalability, very much true. Yes, today you may start thinking that, okay, probably there are around 100 users per day. Let me cater to them. But we may not know. Suddenly our application may become very popular and it may get used by many people. Thereby, always right from day one, think that your application will be used by many. Load will be very high. So think of the scalability things while designing right from day one itself. That is scalability. Then reliability. Your application should be reliable in the sense, for example, somebody makes a payment. Yes, it has to be acknowledged. It has to be acknowledged, and then a notification should be sent. Or whenever the user wants from any place, your application should always keep. It should be always up and running. Or, for example, you have put up some new products that should be shown to the end users whenever they log in and see. They should not see some stale data. You have loaded the products, but it still not come onto the screen. That will be a big spoiler for your business. Or the other way also true. Let us say some of the products you have duplicated, you have removed from your inventory, but still if it is showing up on your product list, nothing like it is very horrible. So now reliable is, yes, whenever user uses the application, he should feel that, yeah, I can rely on this application for these things. It doesn't fail anywhere. I get always the latest. All items are removed. It works smoothly with whatever expectations he has come with. So that should be taken care of. There is another important dimension with respect called reliability. Then performance. Yes, performance is very crucial today. Even a 5-second delay, I think people will switch over to the next competitor. A best example is any website. If you feel that it is yet to load, your finger is already on the plus symbol for the next website, which is, it's a general human tendency, not depending on any app. It's a general tendency. If any delay, if it's not performing up to expectation, yes, people will switch over to the competitor and you're going to lose the market share. So see to that the performance is always maintained right from day one, and keep monitoring, and you have all the tools necessary to look into the performance issues. Any issue, any lag here and there. Yes, one-off cases acceptable. Maybe one day all the cloud servers, something happened technically, everything is down, performance is very slow, something happens. Okay, maybe a very big virus attack is there, some failure has happened, no problem, acceptable, but not always. So you see to that your application performs at any time as expected, as expected. Whatever bar you have set, that has to be consistently. The next one is consistency. The same thing. Now, whatever the users got used to it, that may you maintain that consistency. Provide them with latest thing, whatever you're offering, that should be consistent. It should not vary. For yesterday was something, today is something. No, it should not vary. Maintain the consistency in the application. Then operational complexity. This I'm thinking operational complexity is nothing but um, the usage of the application. From that context, I have few things to say. Operation, when you're operating the application, for example, right from placing the order to the checkout or log off, it should be smooth. No way user should think, oh, what I should do next, where should I go and click next. That thing should not come. So this should be quite simple, and user should feel happy that within a few, probably under a minute, he is able to get all his work done and come out safely with all notification getting received. All that is done. So the whole operational thing should be, application should be smooth. Then cost is definitely cost. It should be cost effective. It should not be too expensive. And it should not be too cheap. Somewhere we have to have a middle cutoff so that it serves it's a win-win situation for both vendors and for the users. Then
Or I think so. We need to focus on, you can say, rather than line by line, we need to focus on a how part, because we already discussed these things,
okay,
right?
right,
So whatever main thing which you need to teach me, which you need to explain me, I think we need to focus on that part.
okay,
You can quickly cover the things, but focus on a main part.
okay. Ah, okay, but I think in that case, 1 minute. Okay. How to decide when simplicity is better? Check whether current arguments are modest. AI, if a scale, team size, complexity was still limited, simplicity is often the better choice. Okay, this is quite simple. Ask whether your future need is proven. Do not build for future scale based only on imagination. Yeah, fine. Okay. Examples unproven assumption. We have millions of users soon. We may need multi-region in future. Yeah, I think already again we discussed this. Okay. Prefer simplicity when it meets the real needs. Yeah, faster delivery or low operational burden, easier debugging, cleaner ownership, and lower cost. Okay. Keep evaluation path open. Simple does not mean careless. A simple design should still allow future growth. Good example, start with modular. Yes, we already discussed this, more modular design. Keep clean domain boundaries. Externalize configuration. Okay, externalize config. Like I think what he meant by here is like you don't hard code values. It should be configurable from one place, and so that it affects everywhere than hard coding. They use contracts clearly. Yes. Um, there should be understanding before we take up any design, any work. There should be a contract very clearly signed, like what is being asked for and what we are going to waive. So all that study has to be done. Only once the contract is signed, only we are going to take up. That means we have been agreed upon on certain things. So we're going to work on those things which we have agreed upon. So that's very clearly done in the contracts. Add asynchronous boundaries only when where okay, asynchronous boundaries only where needed. I think this I'm not getting much of points on this. I have to get this done. Okay, add complexity only when pain is real. Complexity should be introduced when current system creates real bottlenecks, not when engineers feel nervous about the future. Okay, example, a food delivery startup may begin with one main database, background job for notification, cache only for hot reads. That is often better than starting immediately with multiple microservices, distributed QA everywhere, complex event choreography, started database. Yes, I think roughly we discuss on these points. Yeah, now how to evaluate the cost versus performance versus cost. This is a very hot topic, my God. Okay, step one: ask whether performance problem is real. Do not optimize performance just because optimization is possible. Check current latency. Check, that's what. Now, current latency, user complaints, business, okay, fine. Current latency can be got from the feature which were implemented in our design time method. That is nothing but observability and our monitoring systems. So just study that area and then see whether it is really any change in the latency. Okay, then user complaints. Yes, you better have a place where the users can log in their complaints. Once in a while, just go through the complaints and see whether there are genuine complaints or it is one-off complaint. On one user complaining about some 6 months back, there is a problem, but now he is not having any problem. So those things can be filtered out, but still give a place where the users can put their complaints. If there's a common complaint throughout, yes, that means it's a real problem. Address that immediately and see to that there are no more complaints. Then business impact. Okay, adding that business impact. Business impact from which point of view and okay, fine. Bottleneck location. Yes, this can be identified by our observability and monitoring systems. It will tell exactly where the bottleneck is and go and loosen that area or decouple that area so that that should not be any problem for them. And then expected traffic. Expected traffic is, for example, yes, I may say around 100K users per day, but somewhere we may have some 10-20% this side, that side. We can't exactly go for 100K or whatever it is. So yes, and also we should keep in mind, for example, let's say now during you launch this application 7 in the month of October, definitely expect a huge traffic during Christmas time, during New Year time. Then you expect that to go over the from somewhere after Jan 20th or last week of January, the business will become a normal cycle. It won't be that peak. So these are the expected traffic during festival time. You always expect peak traffic. See to that your systems are well in place so that during peak traffic your system doesn't fail. So you know the trends, you know the market, you know the users. So based on that, you see to the applications is well prepared for all these things. Then step two, measure the cost improvement. Oh, okay, yeah. Performance improvements usually cost something. Yes. So, example, if you want to invest on infrastructure, it's going to cost you. If you're going to have more engineering time, that means you're going to pay to your employees more operational complexity. Okay, fine. Then harder debugging. Yes. If the if the team size is small or if the application is built if the application is quite complex and whereby you have not followed certain standards of coding. For example, very simple example I can quote is putting the comments here and there, some naming conventions you have to follow, and then it should be most of them like if you're going for microservices, it has got its own benefits, and then wherever required, use the backend capability. So there are certain things which will help you to debug the application whenever there's a problem. So that is one. And then higher cloud cost. Yes, today the cloud cost is rising day by day. So based on the need, you have to hire the services, and whenever you feel that, for example, let's say now during Christmas time, you expect a huge traffic. Yes, hire a server, do some load balancing. Once the peak season is over, you can simply detach the server from this one. So you don't need it. Maybe you may need after 8 months again. So so those things also should be taken into account. Just because you hire doesn't mean that you should hire it for lifelong. No, for the particular moment I wanted it, I used it, and you can give it back. Use as you use. Sorry, pay as you use. That is the concept of SaaS and your cloud servers. So use it when you want. When you don't need, de-link it from your reserve. So the cost is going to come down.
Okay. So let's discuss whatever point you are not clear about.
Okay.
So because you mentioned some point, I think so you'll come more discussion on those.
Operational maturity. The operation under identify constraints, operational maturity. That here I didn't get it, Deepak.
Operation maturity, how we are talking about this operation means operation should be you can say we can take a time to mature this, or we require it should be work as expected without any failure. Then we need to take a special care of this maturity.
Okay.
You understand my point?
Okay. Fine. Okay.
Next.
1 minute. 1 minute. Let me see now. Yeah. Okay. Now I got it. Then sync workflows. Okay. This is also somewhere you touched upon. That is in synchronous workflow. We expect a response immediately. Asynchronous workflow, response immediately. A best example is a payment is made, but the notification is an asynchronous service where after it can happen in the background. Delivered, for example, item is delivered, the delivery notification will happen in the background. That is a asynchronous system. Fine, that I got. Yeah, here cache now versus optimize DB first.
So means right now you are facing the problem, and due to that problem, you are thinking means, hey, if I will improve the introduce the cache, it will means overall problem will fix. No,
Hmm,
first
hmm.
you need to check the database with the
Okay.
help of improving the query or applying the indexes. If it's improving, then there is then why you are going for caches.
Okay, 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 okay.
That's a thing you need to consider.
Okay, okay. Right. Every option improves some qualities and weakens other. The goal is not perfection. The goal is the best fit for current needs. Um, where is that?
You can control F and paste that line, it will give you the same thing.
Oh no, sorry, 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 sorry.
Just copy that
Yeah, yeah,
line.
yeah, I'm copying it. Yeah, accept. Okay, for step number 5, accept that no option is perfect. Every option improves some qualities and weakens others. The goal is not perfection. The goal is the best fit for current needs.
You understand? Means it depends on client to client requirement. You can
Ah,
think of one. Means we have a five different clients. Am I right?
ah, okay,
And means everyone have their different needs and priorities. Maybe
okay.
whatever you are looking for is the best one for you, but for another it's not best. Am I right? Their
Correct.
best you can say is a different
Ah,
description
ah,
or definition.
ah.
So that's why we need to focus on a, you can say, current needs.
Okay.
We don't need to go with our biases or other things. Am I right? It
Okay,
depends
okay.
upon client to client.
Okay, fine. Okay, right. Add async boundaries only where needed. Like the same example, like notifications can run in the background, asynchronous mode.
Yes. Where means it will take some time. Am I right?
Yes, 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 yes. Okay, then I think in that case it is clear. Okay, fine. Business impact. Business impact. Here I'll tell you from where it has come. Uh,
So business
yeah.
impact
Okay,
as its name suggests, yes.
because coming under whether performance problem is real. So if if the performance problem is real, this it's definitely is going to affect the business. Is that what is meant by?
Yes, yes, yes.
Okay, okay, yeah, right. Okay, fine. Okay, all right. Because it got mixed with little technical part also. Example, latency, then bottleneck location, expected traffic. Okay, no. So performance is a problem, then it's going to affect my business. Correct. Okay, done.
Yes.
Okay. Here. Ah, okay. I think very good technical things. Measure the complexity added. Now, a performance solution may work technically, but create ongoing burden. For example, caching adds invalidation. Caching adds invalidation complexity. Invalidation complexity. Invalidation complexity.
Means let's say your data has been changed in a
Ah,
database, but your cache is not updated. We need to
okay.
think about how we can means change the data, how cache should
Refresh.
be get updated data.
Oh, okay.
So that we need to think of. Am I right?
Oh, okay. Right. Okay. Then pre-computation adds data freshness trade-off. Pre-computation adds data freshness trade-offs. Pre-computation. Pre-computation. Okay, adds data freshness trade-offs. 1 minute. Pre-computation adds data freshness trade-offs. Computation. Okay, this also, okay, only this, not the other one. Okay, here
As
is
its name suggests,
ah,
pre-computation,
ah,
which we need to do measures are valid data or not valid data. This will also mean kind of cache. And
okay,
this is a, whatever we are data we are serving to user. It's a stale or it's a fresh data. We require
ah,
need to kind of this computation.
ah, 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 ah. Okay.
Okay.
Okay. So, okay, that there's a trade-off in that. Okay. Fine. There's a trade-off in that. Okay. Fine. Okay. Okay. Yeah. Sharding adds routing complexity. Yes. Sharding is only when you have very huge data, or when there's a performance issue. One of the solutions can be sharding. Okay. It adds routing complexity. Okay. Fine. Okay. And then specialized storage, specialized storage adds operational overhead, yes. But here, I thought general storage, but what is specialized storage? Like maybe, um,
Cache,
uh,
cache,
oh, that is specialized storage. Okay, fine. Okay,
yes.
okay. But one, so maybe silly question, Deepak. See, cache also, no, I just want to ask, what is the maximum we can have in a cache? Okay, maximum capacity of a cache?
It's totally up to you.
No, but
But
system, today's system, how much it support, how much it supports, yeah, or no, provides max cache. We have something called RAM already. For example, say 64 GB RAM I have. But what can the cache be maximum?
I need to check that.
Okay, that's what. Okay, I just want to know. Okay, fine. Because there may be system limitations also when it comes to cache. Fine. Okay. Ask whether business value justifies it. Yeah, fine. Yes, correct. If the gain is tiny but complexity is large, the trade-offs may be poor. Definitely. Now, my operational, sorry, my number of users are very few. So I don't need to go for a big system or load balancer or vertical scaling up. All that not required. Run with the existing one. Gradually, as and when it is growing, you add. Wow, that too only when needed again. It doesn't mean that overnight you will have a million users added. No, it will be gradual rise. So depending on that, you go for the scalability issues or spend money on the infrastructure, not just blindly. For a small gain, don't spend too much. See, with the existing only, can it be tweaked so that it serves the purpose? Fine. Prefer the
Yes, yes.
smallest. Pardon.
Go ahead, please.
Yeah. Prefer the smallest effective improvement. Beautiful. Before choosing a major architectural shift, consider whether a smaller, yeah, just now we're discussing Fricks works. Yeah, add index before redesign DB. Yeah, now for example, if there's some performance issues with selected to, for example, products, my product list, I'm unable to know. The product search is taking a small delay. It is not what I expect. I want little more speed. Yes, the first immediate reaction can be okay. Let us try to index. That's one of the easiest thing which can be done without incurring any cost. Index and see whether that improves. Uh, if not only we'll see later. Fine. That is one of the option. Okay. Optimize the query before adding cache. Yeah. See, sometimes the query will be so bad. Everything will be fine, but the query is bad. So there are different ways to optimize the query. Study the query pattern, how it fetches the data, where the delay is. Again, there are so many tools available to know how a query is getting executed. Use those tools, study the metrics, and see whether the query can be tweaked. And then with the all existing system, your whole application will normally fine or better after you tweak the query. Then um, tune connection pool before adding more infrastructure. Yes, for example, DBs at a time, say around 100 users are getting connected. Yes, it has got some limit where no, for each user, this separate thread is created and then it will give the connection for each user. But sometimes if it increases, there are some settable things which can be configured, the number of pull connections in the DBs. So see whether those can be tweaked to accommodate more users. Beyond that, there are other ways to address the issue. Next, batch work before introducing full streaming system. Okay, like instead of straight away going for total final execution, go in a batch by batch, then see whether it is running smoothly. Once that is all tested, all metrics are taken into account, then you just go for a full streaming of the application. So in this way, you're safe, everybody is safe. Example, if order search latency is high, the sequence might be, if the order search latency is correct, inspect slow queries, then add indexes, optimize the query patterns, adding caching if still needed, rest, and then redesign storage only if proven necessary. I redesign the storage only if proven necessary. Fine. That is better than jumping straight into a highly complex architecture. Fine. Now again, how to avoid over-engineering? Watch for architecture excitement. Teams often choose advanced patterns because they sound modern or impressive, which may not, for us, it may not be required, but we still go for all that. Yes, that should be avoided. Okay, then ask what problem the complexity solves. Every added component should answer what exact problem does this solve? Why now? What evidence supports this need? Yes, for the last one, we have our monitoring systems in place. So that evidence will tell us whether should go for all this or not. Fine.
No, no, no. These are different. This metrics and observability come after implementation, am I right? But means let's say you are need to justify why you are going with this.
Okay.
You understand my point?
Okay. Fine. Okay.
There are a lot of options are there why you are opting this only.
Okay.
When you move forward, you will get this. Means you
Okay.
need to communicate with the stakeholder as well. Right?
Correct. Yes. Okay. Count the operational burden. Count the operational burden. Each new component may add deployment overhead, monitoring overhead, debugging burden, security surface area, then team coordination cost. Okay, yeah. Okay. Check team capability. Yeah, very important. Design must match the team's ability to build and operate it. Very important. If the team is unable to do, then nothing will happen. Okay, fine. So design must match the team's ability to build and operate it. Okay, fine, right. But here again, one doubt in the background, Deepak. Now, let's say now our team is not that capable. Then probably I may think of giving them, arranging some training sessions for them,
Yes, yes,
or take one a senior with little more experience in all these areas, put him as a main lead, and this the existing can be a shadow resource, just learn from him, and then these are the measures as we can take, right?
yes.
Okay, fine. Right. Prefer because I can't complain to client stating I don't have team which can do all this. Okay. Prefer reversible decisions early. In uncertain systems, start with choices that are easier to change later. Sorry, in uncertain system, okay, start with choices that are easier to change later. Okay, fine. Okay. And again, same example probably. Monolith, start with monolith, then gradually go for microservices based on the need of the hour there. Okay.
Yes,
Example, same examples here. Using a model monolith early is often more reversible than starting with many tightly coupled microservices and then trying to simplify later. Okay. So start with simpler, then go for this one. Okay, fine, right. Okay. How to think technically debt correctly. How to think about technical debt correctly. Separate conscious debt from accidental debt. Okay, fine. Conscious debt is a deliberate shortcut taken for speed with known consequences. Accidental debt is poor design created without awareness. Okay, fine. Yeah. Okay. Just because, okay, we are going by the flow, just because industry is having using the latest technology, go for the latest buzz and put all that, and we'll be in trouble. So let it be a conscious decision in any step you take. It should be a conscious decision, not just by the today's trend or what is happening around, or my competitor using that, why not I use that also. No, that may not serve the purpose. No, that again, some conscious decision should be taken for anything you do. Fine. Take that only for a reason. Good business may include urgent launches deadline, temporary market opportunity, experimental product validation, internal prototype phase. Okay. Record the trade-offs clearly. Document what shortcut was taken, why it was taken, what risks it creates, when it should be revisited. Okay, the trade-offs. Okay, fine. Record it. Okay, and okay, what shortcut was taken. Okay, fine. Limit debt on critical path. Debt in core payment. Yeah, debt in core payment, security or data integrity path is more dangerous than debt in low risk internal tools. For example, yeah, I can take a risk in notification area, but not in payment area or security area or data integrity area. Yes, I should be very, very conscious while doing all these things. Yes, okay, fine. Right. Then plan the payback path. Payback path. Debt is manageable only if cleanup is intentional. Okay, debt is manageable. Yeah, only if cleanup is intentional. Okay. Example, a team may choose synchronous notification, sending temporarily to ship faster. That may be acceptable if they know it may increase user-facing latency. It may need asynchronous decoupling later. The change is isolated and reversible. Okay. Again, how to make scalability decisions wisely? Oh, very important. Measure current load. Again, okay, fine. Current load and growth. Do not design scale solutions without evidence. Check.
Hello, Sridhar. Are you there?